Hey guys, welcome to this session by Intellipaat. So there's a huge demand for Python and Python programmers out there. Being versatile in nature, Python can be used for web development, machine learning, deep learning and multiple other tasks. So now you guys must be wondering what sort of questions are asked by the top companies when it comes to a Python interview. So in today's session, we've come up with this Python interview questions so that you can ace any Python interview that you attend. Now you guys also have to make sure that you implement all of the coding part by yourselves so that you gain the required expertise. Now let's actually start off by having a glance at the job trends of different programming languages. So here we are comparing Python, R, Angular and C. And it's very obvious that Python is the most preferred language across various industries. So you see this blue color line over here. So this blue colored line is for the Python programming language. And if you closely observe this blue colored line, you will observe that the popularity of Python has been steadily increasing over the years. So now that we know how popular Python is, let's head on to our interview questions. Right, so this is our first question. What are keywords in Python? So you can consider these keywords to be special reserved words which exist for a specific purpose. Now you cannot use a keyword name as a variable name or an identifier. So these are some of the keywords which exist in Python, such as true, false, not, continue, and so on. And in total, there are 33 keywords in Python 3.7. Now you also need to keep in mind that these keywords are case sensitive. That is, if you look at the keyword true over here, then you see that T needs to be capital. So our next question is, what are literals in Python? And then we'll have to explain about the different types of literals. So literals are the constants used in Python. Or in other words, this is the data which is stored in a variable. And there are 4 types of literals in Python. So we have string literals, numeric literals, boolean literals, and special literals. So let's look at string literals. So you can create string literals by just enclosing the text within quotes. So here we have created 2 string literals, John and James. So we see that John is enclosed double quotes and James is enclosed within single quote. So this is how you can create string literals. Next up, we have numeric literals. So numeric literals comprise of all of your digits. Now if your numeric literal doesn't contain any decimal, then it is of the integer type. And if your integer is too long, then it would be of the long type. And if your literal consists of a decimal point, then it would be a float. And finally, we have a complex number which consists of a real part and an imaginary part. Going ahead, we have Boolean literals. So these Boolean literals comprise of just true and false values. They are generally used when we are dealing with some condition whose output is either true or false. Now we'll head on to special literal. So Python consists of this special literal called as none, and it is used to specify a field that is not created. Here in this example, I have assigned none to the variable val2. So this variable would basically be empty. So this is our third question. What is a dictionary in Python? And we'd also have to create a dictionary where the key is fruit name and there are 4 fruit names as values. So a dictionary is an unordered collection of elements, and these elements in a dictionary are stored as key value pairs. For example, here we have a dictionary with the name my dictionary and we have 3 key value pairs. So here our first key is 1 and the value for this key is John. Second key is 2 and the value for this key is Bob. And then we have the final key which is 3 and the value for this is Alice. Right, now let's head on to Jupyter Notebook and create our own dictionary where the key is fruit name and the values would be 4 fruit names. So I'll name the dictionary as my dictionary. And we can create a dictionary with the help of these curly braces over here. So I'll give in the key name which would be fruit name. And after this, I'd have to give in values of 4 fruit names. So let's say my first fruit is apple. And then the second fruit is mango. Third fruit would be orange. And the fourth fruit would be guava. Now all I have to do is hit on run and then let me print this out. So I'll just type in my dictionary over here. Right, so we have created a dictionary with the name my dictionary where the key is fruit name and the values are apple, mango, orange and guava. And if you want to extract the individual key and individual values, this is how we can do it. Now I'll type in the name of the dictionary, which is my dictionary. I'll put in dot and then I'll just type in keys. I'll click on run, and we see that the key for this dictionary is fruit name. Similarly, if I want all of the values, I just have to type in values over here. Now let me click on run. So for this dictionary, the values are apple, mango, orange, and guava. So our next question, what are classes and objects in Python? So simply put, you can consider a class to be a blueprint and objects to be real world entities which are defined and created from classes. For example, over here you can see the actual blueprint of a house. Now, this blueprint can be used for the rapid creation of unlimited number of copies. So these copies of the blueprint are nothing but your objects. And here we have created 3 houses, or in other words, 3 objects from the original blueprint, which is our class. So I'm repeating it. So our class is nothing but a blueprint, and from this blueprint, we'll be creating a set of objects which are our real world entities. So over here, this house number 1, house number 2, and house number 3 are our real world entities, which are nothing but objects created from this class. Next, we'd have to create a simple class with the name human, which would give out the name and age of the person. So let's do this. Right, so to create a class, I'd have to use the keyword class, and then I will give in the name of the class, which would be human. Now inside this, I will create 2 variables. So the first variable would be name, and initially I'll just assign none to it. And my second variable would be age. Again, I'll assign none to it. So we have created our variables. Now we'd have to get the value of name and the value of age from the user. So for this, I'd have to create some definitions or methods. And to create a definition, I'll use def. After this, I will give in the name of the method, which would be getName. And inside this, I will pass in self. Alright. So now over here, I'll just use the print function and type in enter your name, and after this I will get the name and the self.name. So basically self.name basically means that whatever value the user enters, it would be stored in this name variable of the object, right? And I'll just type in input over here. So this input function is used so that we can get a value from the keyboard, right? So this is how we can get the name of the person. Now similarly, let's go ahead and get the age of the person. So I'll type in def, and I'll name this method to be getAge. Again, I'll pass in self inside this. Right. This time I'll use print, and I'd have to enter the age. So enter your age, and then I'll store this in self.age equals input again. Right. So we have created 2 get methods where we'll be getting the name and the age of the user. Now after this, we'd have to print out the name and the age. So it'll be def, and I'll create the method to be put name. Again, this will be self, and I'll just print out the user's name. So your name is self.name, and then similarly, I'll create another method which would be put age, and I'll pass in self inside this. So for this, it would be print of your age is. Let me again put in double quotes over here. Right. So your age is, it would be self.age. So we have created our class where we have 2 variables, name and age, and I've created 4 methods. And out of those, from those 2 methods, I'll be getting the name and age of the person, and the rest of the 2 methods would help me to print the name and age of the person. Right, I'll click on run. So we have created this class. Now once we create our class, which is basically our blueprint, we'd have to create the objects from this class. So let's say I create an object and name that object to be person1. Now this would be our first instance, and I just have to call in human. So I'm creating a person instance of the human class. Now, from this person object, I will invoke the getName and getAge methods. So person1.getName. Let me click on run. I'd have to enter the name of the person. Let's say the name of the person is Sam. Right, so now it's time to get the age of the person. So I'll type in person1.getAge. I'll click on run. And let's say the age of the person is 28. So now I have successfully feeded in the name of the person and the age of the person. Now it's time to print out both of those. So it'll be person1 dot put age and person1 dot put name. So person1 dot put name. Right. So your age is 28 and your name is Sam. Right. So we have successfully created our class which would print out the name of the person and the age of the person. Right. So next question. What do you understand by the init method in Python? And after that, we'd have to give an example of it. So you can just consider the init method to be a sort of constructor in Python. So it is a special method in a Python class which is used to initialize the variables. So now that we've understood what init method is and what it is used for, let's go ahead and work with this init method. So now over here, what I'm going to do is create a student class with the init method in it. So let me do that. Class student, and over here, I'll just create the init method, and these are the parameters of this init method self. So, and after this, it'll take in the name of the person, and after name, it'll take in the age of the person, and after this, it'll take in the branch of the person. Right. Now, what I have to do is just store these values inside the original variables. So that'll be self.name equals name, and then our next variable is age. So self.age equals age, and then we have the final variable which is branch. So it would be self.branch equals branch. So we have created our init method. Now after this, wait, so we actually have to put in def over here because this is actually a method, right? So we have created our init method, which is basically a constructor, and going ahead, we'll just create another method which would help us to print all of these values. Def print student, and I'll take in self, and all I do over here is print in all of these values. So print of name would be self.name. After this, we have age. So let me change this to be age over here, and this would be self.age. After this, we'll have to print in the branch. So let me just put in branch over here, and this would be self.branch, right? So we have created the student class which has the constructor. I'll click on run. Now let me create an object of the student class. I'll name the object to be student1, and let me go ahead and create an instance of this. Now, since we have this constructor over here, so I can go ahead and initialize the student object here itself. So I'll give in the name of the student. So let's say the name of the student is Bob. After this, the age of the student is 12. And then which branch is he studying? So let's say this guy is studying engineering. Let me just put in engineering over here. Run. Now student1 dot, I will call in the print student method over here. Right, so we have successfully created this instance student1. Right, so what do you understand by inheritance in Python? And then we'd have to give an example of it. So inheritance refers to the property of one class acquiring the properties of another class. For example, let's say you have inherited your features or properties from your parents. So if you see over this family tree over here, you can understand that traits such as hair color and poor eyesight are passed from one generation to the next generation. So over here, this is generation 1, generation 2 and grandparents. So your parents are inheriting their traits or their features from their grandparents, and you are inheriting your traits from your parents. Now let's go ahead to Jupyter Notebook and work with an example of inheritance. So here what we are doing is we have a base class with the name fruit, and this base class is being inherited by another class, citrus. Now this is our base class fruit, which has a constructor, and this constructor just prints out I am a fruit. Now after this, what we are doing is we are creating another class with the name citrus, and this class inherits from the fruit class, right? So if a class has to inherit another class in Python, we'll just give the name of the base class as a parenthesis inside our new class. Now again, inside the citrus class, we have created another constructor, and inside the constructor of the citrus class, I am using the super method. So with the help of super method, I can invoke the variables and functions from my super class, right? So over here, I want the init method from my super class. So I'll just use this super method, and I'm invoking the init method from this fruit class. Now, apart from this init method from the fruit class, I would also print something else. So over here, I am also printing I'm citrus over here, right? And I'll create an instance of this class citrus, and I'll store it as lemon. Now the result is I'm a fruit, I'm citrus. So this value I'm a fruit is coming from the super class, and this value I'm citrus is coming from our new class or the child class. So this is how we can do single level inheritance in Python. So next, so what is NumPy and how can you create a basic 1D and 2D NumPy array? Well, NumPy is the most widely used Python library for linear algebra, and it is used for performing mathematical and logical operations on arrays. And to import the NumPy library in Python, you just have to use the command import NumPy. So again, let's head to Jupyter Notebook and create a 1D NumPy array and a 2D NumPy array. So I'll start off by typing import NumPy as NP. After this, I'll create my 1D NumPy array. So A equals NP dot array. Now I will give in a list of values. So this is my 1D array A, and then let me just print it out. So this is my 1D array which comprises of the values 1, 2 and 3. Now I'll go ahead and create a 2D array with the name B. So again, the syntax would be the same, np dot array. So it'll basically comprise of a list of lists. So the first list would comprise of 1, 2 and 3. And the second list would comprise of 4, 5 and 6. Let me print this out. Right, so this is our 2D array which comprises of 1, 2, 3, 4, 5 and 6. So this time we'd have to initialize a 5 cross 5 NumPy array comprising of all the zeros. So it's a 5 cross 5 NumPy array, that is there need to be 5 rows, 5 columns and all of the values need to be 0. And to initialize an array with all zeros, we can just use np.zeros method from the NumPy library. Let me just type in import NumPy as np, and inside A, I'll just state np.zeros, and I'd have to give in the dimensions of this array. So the dimensions of this array are 5 cross 5. Let me just print out A. So we have successfully created our 5 cross 5 NumPy array where all of the values are just zeros. Now, let's say we have two NumPy arrays like this. So this is our first NumPy array. This is our second NumPy array. First NumPy array comprises of 1, 2 and 3. Second NumPy array comprises of 4, 5 and 6. Now, I'd have to add the individual elements. So 4 plus 1 needs to become 5. 5 plus 2 needs to become 7. And 6 plus 3 needs to become 9. Again, our first step would be very simple. I'd have to load the NumPy library, import NumPy as np. I will go ahead and create my first NumPy array, A equals np.array. And the values are 1, 2 and 3. Similarly, I'll create my second NumPy array, which is B. I'll change this variable to be equal to B, and the values are 4, 5 and 6. Now, to add the individual elements, I'd have to use the np.sum method. Now inside this, I'd have to give in my first parameter. So my first parameter would be the NumPy arrays which I'd have to add. So I want to add A and B. And I will set the axis to be equal to 0. So when I set the axis value to be equal to 0, this would individually add the elements. So this will do 4 plus 1, 5 plus 2 and 6 plus 3. Right, and this is what we have. 4 plus 1 is 5, 5 plus 2 is 7 and 6 plus 3 is 9. Now let me actually change the axis value to be 1 and let's see what do we get. Right, so when I change the axis value to be 1, then the addition happens across the row. So when you do 3 plus 2 plus 1, you get 6, and when you do 6 plus 4 plus 5, you get 15. So now we'd have to get the n largest values from a NumPy array. So this is our NumPy array over here. and this comprises of 1, 2, 3, 4, 5, 6, 7 elements, 12, 43, 200, 54, 5 and 68, and I'd have to get the first two largest values, which over here are 100 and 68. Now let's go to Jupyter Notebook and let's see how can we do this. Right, so again we'll start off by importing the NumPy array, import NumPy as NP, and I'll create this array. X is equal to np.array, and I'll give in all of these values. Now to get the indices of values which are arranged in ascending order, we can use the np.argsort function. Now what I'll do is I'll actually insert a cell below, and I'll go ahead, I'll do Control X, I'll do Control V. So we have successfully created our NumPy array. Let me just print in X over here. So this is our NumPy array. Now what I'll do is I'll just copy this np.argsort of X, and I will print it over here, and let's see what do we get. So what we get over here are index values. So 0, 1, 2, right? 0, 1, 2, this is our lowest value. And then we have 5, so element at index number 5. 0, 1, 2, 3, 4, 5, right? 2, 5, and then we have 0, which is 12, and then we have 43, right? So we basically have the indices of the values arranged in ascending order. So 2, 5, 12, 43, 54, 68 and 100. So this is how it goes. Now if I want the indices of the first two highest values, then I'll just put in -2 colon over here, and I have 6 and 3, right? 0, 1, 2, 3, 4, 5, 6. So 68 is the second highest value, and then we have 3, 0, 1, 2, 3, right? So 100 is the first highest value. Now what I want to do is I want to arrange this in descending order. So to arrange this in descending order, again, I'll put in braces over here, I'll put double colon, and I'll put in -1 over here, and I have sorted the indices in descending order. Now if I take all of this, I'll cut this, and I will paste this inside of X. I'll click on run, and this is how I get the first two highest values from this NumPy array. So 100 and 68 are the two highest values from this NumPy array. So now we'll have to give some examples for creating a data frame from list and dictionary. So this is a very common and easy question which is asked in most of the Python interviews, right? So first we'd have to go ahead and create a list, and we'd have to convert that list into a data frame. Similarly, we'd have to create a simple dictionary and convert that dictionary into a data frame. So I'll type in import pandas as pd. So I'd have to start off by importing the pandas library. Now I will go ahead and create a list. So I'll name this list to be equal to L1. So L1 equals 1, 2, 3, 4, 5. So we have created our list. Now to convert this list into a data frame, all I have to do is use pd.dataframe function. So over here we need to keep in mind that D is capital, right? pd.dataframe, and I will pass in L1 inside this, and I will store this in, let's say, data1, and I'll just print out data1 over here. So we have successfully created a data frame from a list where the list values are 1, 2, 3, 4 and 5. Now similarly, we'll create a dictionary and create a data frame out of that dictionary. So I will name this dictionary to be dt1, and the key is fruit name, and the values are apple, mango, and let's say orange. After this, we'd have to create our second key value pair. So our second key value pair would be count, and the values would be, let's say, 12, 24 and 36. Right. So we have created this dictionary. Now again, to convert this dictionary into a data frame, we'd have to use pd.dataframe, and I will pass in dt1 inside this. Right, so we have created this data frame where our first column is fruit name and the second column is count, and fruit name comprises of apple, mango and orange, and the count of the fruits is 12, 24 and 36. So now we have this iris dataset which comprises of all of these columns. So we have sepal length, sepal width, petal width and species. Now out of this we'd have to extract some specified rows based on a condition. So we'd have to extract only those records where the sepal length value is greater than 5 and the sepal width value is greater than 3. So I'll start off by loading the pandas library, import pandas as PD. And after this, to load a CSV file, I'd have to use the pd.read CSV function. And I'll give in the name of the file. So the name of the file would be iris.csv, and I'll just store this in a new object and name that object to be equal to iris. Now let me have a glance at the head of this data set. Iris.head. So this will give me a list of the first few records, right? Sepal length, sepal width, petal width, and species. Now let's see how can we extract only those records where sepal length is greater than 5 and sepal width is greater than 3, right? So I'll start off by giving the name of the data frame, and I'll put in these braces over here, and I'll give in the first condition. So the first condition is again iris, and from this I'd have to select only those sepal length columns where it is greater than 5. So sepal dot length, this value needs to be greater than 5. So I've given my first condition. After this, I'll go ahead and give my second condition. And this time I'd have to extract only those records where sepal.width. Let me type this out. And this needs to be greater than 3. Now let me also put this inside these braces over here. Let me cut this and let me paste it over here. I'll click on run. Right, so this is our list of values where sepal length is greater than 5 and sepal width is greater than 3. If I scroll down, you'll see only those values where sepal length is greater than 5 and sepal width is greater than 3. So what we do is, we given the first condition where sepal length is greater than 5. After that, we'll use the AND operator, and then we give the second condition, which is sepal width is greater than 3. Right, so after this, we again have this iris data frame over here, and we'd have to introduce NaN values or null values in the first 10 rows of sepal width column and petal width columns. So if you see this original data frame over here, you see that these two columns comprise of some values. But then again, we'd have to fill the first 10 rows of these two columns with NaN values. So I'll start off by loading the required packages, which would be Pandas and NumPy. So import Pandas as PD and import NumPy as NP. After this, I'll load the iris dataset. So iris equal to pd dot read CSV, and I will pass in the name of the dataset, which is iris.csv. Let me again have a glance at the head of this dataset. So iris.head. Right. So now to introduce NaN values, I can use the np.nan method. So now what I'll do is I'll actually create a duplicate copy of this object. So iris1, and I will store this data frame into iris1. Now I'll type in iris.ilock, and I would want to make changes in the first 10 rows and the second column. And the second column, right? So first 10 rows and the second column. So the index of the second column would be 1. And what I'll do is I will introduce all of the NaN values. So np.nan, let me put an equal to over here. Now let me have a glance at the head of this modified data set. So iris1.head, right? So we see that this is our original data frame. And with the help of np.nan, I have introduced NA values from actually the first row. So let me actually change this to be 0 over here. I'll click on run. So now I have NA values for the first 10 records. Similarly, I'll also go ahead and introduce NA values in the petal length column. So over here, I just have to change the index of the column, which would be 2. Let me have a glance at the head, iris.head. Right, so now we'd have to get the number of NaN values present in each column of this enhanced data frame. So this is our data frame over here, which comprises of these columns. So we have age, BMI, HYP, and CHL. And we see that these 3 columns over here comprise of NaN values. And we'd have to find the count of the NaN values present in each of these columns. So I'll start off by loading the Pandas data frame. I'll type in import pandas as pd. Let me just wait till the package is loaded. Right, so now that we've loaded the package, I'd have to load the CSV file, which is enhance.csv. And for this, I'll be using pd.readCSV function. And I'll give in the name of the file, which is enhance.csv, and I'll store this in a new object and name that object to be enhance. Now, if I want to get the count of number of NaN values, this is what I'd have to do. Enhance dot, so I have this na function, and after this, I will just print it out. Let's see what do we get, right? So we just get a bunch of true or false labels. So wherever there is an NaN value present, we have a true label. So over here in the BMI column, the first record, this is an NaN value. This again is an NaN value. So wherever you see true values, it basically represents all those NaN values. And if I want the sum of all of these NaN values, I just have to type in sum, and now I click on run. Right? So you see that age column has no NaN values, BMI column has 9 NaN values, HYP column has 8 NaN values, and CHL column has 10 NaN values. Now we'd have to open and read a file in Python. So let's see how can we do that. So I actually have this file with the name Sparta, and it is present in my D drive. So let me actually copy the path over here. Right, so this is just the path which I have to copy. So first, to open a file in Python, I'd have to use the open function. So I'll just type in f equals open, and this takes in two parameters. The first parameter is just the path, and after the path, I'll give in the name of the file, which would be sparta.txt. And the second parameter is the mode which I want to open this file. So I want to open this file in the read mode. So again, I'll just give in double quotes and I'll type in R. So R basically means that I am opening this file in the read mode and I'm storing this in this object F. Now let me go ahead and read this. So F dot read. Right. So this is the sentence which was stored in this file. This is Sparta, and we have successfully read the sentence. So let's head to the next question. So what is a lambda function? And we'd have to create a simple lambda function to add 10 to a given number. Well, a lambda function is an anonymous function, and it can take any number of arguments, but it should have only one expression. And this is the syntax of a lambda function. So you'll type in lambda, and then you'll give in all of your arguments. After that, you'll put in a colon, and then you'll give the expression. So let's go ahead to Jupyter Notebook and create a simple lambda function to add 10 to a given number. Right, so let me just type in lambda, and I'll give the name of the variable to be a. I'll give a colon, and all I have to do is add 10 to whatever variable is sent into this. And I am naming the function to be, let's say, x. So this is how we can create a simple lambda function. Now I'll call the function and pass in a number. So let's say I'll pass in 8. Now this is returning 18. So all I'm doing is adding 10 to the number which I'm passing into this. Now again, let's say if I pass 5 into this, I'll get 15. Similarly, let's say if I pass 100, I'll get 110. So we have successfully created a lambda function which takes in a parameter and adds 10 to the given parameter. So now we'd have to create a simple line plot like this, where x and y axis values range from 0 to 10. And the title of the plot is y versus x label is x-axis, y label is y-axis. So a simple line plot, and we can create this line plot with the help of the Matplotlib package. So let's quickly head on to Jupyter Notebook. I'll start off by loading the required packages. So I would need the NumPy package. So I'll type in import NumPy as np, and I would also need the Matplotlib package. So I'll type in from Matplotlib import pyplot as plt. Alright, so now that we've loaded the required packages, let's go ahead and create our data. So our x-axis and y-axis values range from 0 to 10. So I will name x, and I'll get the values with the help of np.aRange. And since the values go from 0 to 10, 0, 10, and the step factor is 1. So let me just print out x over here, and let's see what do we get. Right, so these are all of the values which I have over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, Now similarly, let me also go ahead and create the y values. It'll be the same thing over here. It's just that instead of storing the values in x, I'll be storing them in y. So I have my x and y values to be ready. All I have to do is use these data points and create the line plot. So plt dot plot, and I'll pass in x comma y, and this is my plot over here. Now I'll also go ahead and add the labels for x-axis, y-axis, and I'll also give in the title. plt dot x label. So the label would be x-axis. Similarly, plt dot y label, and the label would be y-axis for this. After this, I'd have to give in the title. So the title would be plt dot title and x versus y. Right, so we have created our line plot where the label of x-axis is x-axis, the label of y-axis is y-axis, and the title of the plot is x versus y. So it's as simple as that, guys. So this is how you can create a simple line plot with the help of the Matplotlib package. So now we'd have to create a simple bar plot. And we have these fruits over here represented on the x-axis. So we've got apple, banana, and orange. And we've got the cost of the fruits on the y-axis. So let me start off by loading the required library. From Matplotlib, I'll be importing pyplot as plt. After this, I just have to create my data. So I'll be creating a simple dictionary over here, and I'll name this dictionary as data. I'll put in braces over here, and it consists of 3 fruits, which are apple, banana, and orange. So apple, and cost of apple would be, let's say, $50. After that, we have banana, and the cost of banana is 20. After that, we have orange, and the cost of orange is 30. Right. So now I'll separate the keys and values from this. So let me get the keys first, data.keys, and I'll get the list of this. I'll paste this inside this, and let's say I'll store this in an object named as names. Now let me get all of the values similarly. Values, and I'll be getting data.values. So I have the names, I have the values. Now all I have to do is make a bar plot. And to make a bar plot, I'll be using plt.bar, and I'd have to pass in the names as well as the values. Right, so we have successfully created a bar plot, and on the x-axis we have the names, and on the y-axis we have the cost. Next question. So what do you understand by a module in Python? So when we write everything in a single page, it becomes difficult to track. And not just this, let's say if you want to make a change at a certain place in the project, then it would affect the entire project and may prove to be disastrous. And this is where we'll be using the concept of modules. So instead of writing one big software in one page, we would have to break it down into parts. So a module basically helps us to organize our Python code. Now let's say you want to write a program to create a calculator. Now instead of writing all of the features in the same file, you can create separate modules for addition, subtraction, multiplication, and division. Now if you want to perform addition, you can invoke the addition module. Similarly, if you want to perform multiplication, you can invoke the multiplication module. So for every single purpose, you can have a separate module so that your work becomes easier. So now we'd have to randomize the items of a list in place in Python. So let's say we have a list which comprises of these elements. So let's say the first element is Mary, and then we have had a little lamb. Now I'd have to randomly shuffle all of these elements inside the list. And to randomize the items of a list, we can use the shuffle function. And the shuffle function is part of the random library. So I'll type in from random import shuffle. So I have loaded the function. Now let me go ahead and create the list. Mary had a little lamb. Right. Now I will just pass in this inside the shuffle function. Now let me print in X, right? So this is in place shuffling inside the list, right? So initially the list was Mary had a little lamb, or the sequence of the elements inside this list was Mary had a little lamb. And after passing this list inside the shuffle function, the elements changed and the sequence now is a lamb Mary had little. So now we'd have to write a program to get the length of the string ophthalmology without using the len function. And to get the length of the string, we can just use the for loop. So what we'll do is we'll start a for loop and it will iterate through all of the characters in this string and we'll get the count of the number of characters present in the string. So let me name the string. So it is OPHTHALMOLOGY. So let's hope this is actually the spelling of ophthalmology. Right, now let me initialize a counter and set the value of counter to be equal to 0. After this, I'll start the for loop. So for I in A, what would basically happen is count equals count plus 1, and finally I'll print out the value of count. So what is happening over here is initially i's value is 0 and it will loop through all of the characters of the string which is present in A. And so let's say the loop starts over here. Initially i's value is 0 and it will enter O. Now the count increments by 1. Again it will head to the next character, the count again would increment by 1. It will head to the next character and the count would increment by 1. So till the end of the string, it will keep counting the number of characters present. Right, and we get the result. So the number of characters present in the string is 13. So now we'd have to replace all the odd numbers in this NumPy array to -1, right? So this is our NumPy array which comprises of the numbers from 0 to 9, and we'd have to replace all of the odd numbers. So 1 would become -1, 3 would become -1, 5 would become -1. So wherever odd numbers are present, all of those odd numbers would become -1. Let me load the NumPy library, import NumPy as NP. After this, what I have to do is create my NumPy array. So ARR equals np.arange, and it will go from 0 to 10. Let me just print out this NumPy array over here. This is my NumPy array. Now let me go ahead and replace all of the odd values with -1. So what I'll do is I will basically divide each element with 2 and see what is the remainder. So ARR %2, and if it is equal to 1. So what I'll do is I will divide 0 with 2, I'll check the remainder. Similarly, I'll divide 1 with 2 and I'll check the remainder. I'll divide 2 with 2 and I'll check the remainder. So wherever the remainder is equal to 1, those elements I'll be changing it to equal to -1, right? So first I'll divide 0 with 2 and I'll check what is the remainder. And since the remainder is not equal to 1, nothing will happen. After this, I'll divide 1 with 2 and I'll check the remainder. So if the remainder is equal to 1, I'll replace this with -1. Similarly over here, if I divide 3 with 2, the remainder which I'll be getting is 1. And again, this value would be replaced with -1. Right, so the changes have been done. Now let me print this. This was my original array. After performing this step over here, all of the odd values have been replaced with -1. 1 has been replaced with -1, 3 with -1, 5 with -1, 7 with -1, and 9 with -1. Now we'd have to perform an operation so that we get the common items between two NumPy arrays. This is our first NumPy array. This is our second NumPy array. Now let's actually check the common items. So if we look closely at these two arrays, we see that 2 and 4 are the only two common items present among these two arrays, and I'd want to extract these two. Right, so we have created our arrays over here. This is the first NumPy array and I'm storing it in A. This is my second NumPy array and I'm storing it in B. Now to get the common elements, I have the np.intersect1d method. So np.intersect1d, and I just have to pass in the two NumPy arrays inside this as the parameters. So A, B, I'll pass in these two, I'll click on run. Right, so I've got the common elements present in these two arrays. Right, so we have a Pandas series over here, and we'd have to convert each of these elements into title case. So Mary had a little lamb. So we see that all of this are in small cases. Now I'd have to convert all of these elements into title case. So let me start off by loading the Pandas library. import pandas as PD. Now I'll create the series pd.series and I'll pass in the values, which are basically Mary had little lamp. Right, so this is done and I'll store this in, let's say, ser. So I have created my series. I'll just print it out now, right? So this is my Pandas series. Now I'd have to convert all of these elements into title case. That is, M needs to be capital, H needs to be capital, A, L and L needs to be capital, right? And as I've already told you, we'll be using the map method, which helps us to replace or substitute values or all of the values inside a Pandas series. So ser.map. Now inside this, I'll use a Lambda function to convert all of these elements into title case. So let me type in Lambda over here, X, colon, and I just have to convert this into title case. So let me just put in title over here. Now let me click on run. Right, so we have successfully converted all of these elements into title case. Now let me store it back to ser. Now let me print ser over here, right? So all of these elements have been converted into title case. So now we have the same Pandas series. So Mary had a little lamb. Now I'd have to calculate the number of characters in each word of the series. So this is 1, 2, 3 and 4. So there are 4 characters present in the word Mary. There are 3 characters present in the word had. This is a single character, right? So we'd have to find out the total number of characters present in each words or each of these elements inside this Pandas series. Import pandas as PD. Let me again create the series ser equals pd.series and I'll give in all of the elements. Mary had a little lamb. So now to get the length of each of these words present in this Pandas series, I'll have to use the map method. So ser.map, and inside this, I'll again create a new Lambda function, lam bda a colon, and since I have to get the length, I'll use the length function, and I have to get the length of each of these elements inside a. Right, so we see that the length of the word Mary is of 4 characters, in had there are 3 characters, A is a single character, and in little there are 6 characters, and in the word lamb there are 4 characters. Time for next question. So again we have this iris data frame, and we'd have to change the column name sepal length to s_length. Let me load the package, import pandas as pd, and I'll also load the file, so pd.read CSV, and the name of the file is iris.csv, and I'll store it back into iris. Let me have a glance at the head of this data frame. So it'll be iris.head. So we have all of these columns over here, and I'd have to change the name of the sepal.length column to s_length. So to rename the columns of a data frame, I have the pandas.rename method. So first I'd have to give in the name of the data frame, which is iris, and then I will invoke the rename method. Now I'd have to give in all of the column names which I'd want to change. So I'll type in columns over here, I'll create a dictionary, and my key would be the name of the column which I'd want to change. So I would want to change the name sepal length to be equal to s_length. So it'll be s_length. So this is how it goes. So iris.rename, and the original column name is sepal.length, and I'd have to change it to s_length. And I'll store it in a new object and name that object to be equal to iris1. Now let me just print out the head of this. So iris1.head. So now we'd have to build a linear regression model on top of this Boston data frame, where the independent variable is this RM column over here, and the dependent variable is this MEDV column over here, and the train and test split needs to be equal to 80-20. So this question is basically related to machine learning with Python, where we are implementing a linear regression model on top of this data set. to understand how does this MEDV column vary with respect to this RM column. Or in other words, MEDV column is our dependent variable and RM column is our independent variable, and we are trying to understand how does MEDV change with respect to RM. So let me start off by loading the Pandas library, import Pandas as PD. Right, now we'll go ahead and also load up our Boston dataset. So pd.read_csv helps me to load up the dataset, and the name of the dataset is boston.csv, and I'm loading this file in this object Boston, and then I'll have a glance at the head of this. So these are all of the columns which are present in this data frame. So I've got Crim, Zn, Indus, Cas, Knox, RM, and so on. And MEDV is my target and my feature is RM, or in other words, MEDV is my dependent variable and RM is my independent variable. Now I'll separate the feature and the target, right? So pd.data frame, and so from this entire Boston data frame, I am selecting only the RM column and I am storing it into the X object. Similarly, from the entire Boston data frame, I am selecting only this MEDV column and I am storing it into this Y object. So X would have the feature values and Y would have the target value. So now I've extracted the feature and the target. Now it's time to divide this dataset into training and testing set. So the train test split needs to be 80-20, or in other words, 80% of all of the records would be present in the training set and 20% of all of the records would be present in the testing set. And to do this, I'd need the train test split from sklearn.model selection. So I'll type from sklearn.model selection, import train test split, and this method takes in these parameters. So first I'd have to pass in the features and then I'd have to pass in the target. So X, Y, and then I'd have to give in the test size. So the test size is 0.20. So this again means that the test set would comprise 20% records and the train set would comprise of the 80% of the records. And the values would be stored in Xtrain, Xtest, Ytrain, and Ytest. So Xtrain would comprise of all of the training values or all of the training records for the features. And Xtest is basically the test set for the features. Ytrain is the train set for the target and Ytest is the test set for the target. So we have our training and testing sets ready. Let me click on run over here. Alright, now it's finally time to build the model on top of the train set. So from sklearn.linear model, I will import the linear regression and I'll create an instance of this. So I'll name that instance to be regressor and I will fit this model on top of Xtrain and Ytrain, or in other words, I'm fitting the model on top of the train set. Right. So now that we've fit the model, it's finally time to predict the values on top of the test set. And to predict the values, I'll use regressor.predict, and the parameter which I'm passing inside this is x_test, and I'll store this in y_pred. Now, once we predicted the values, I have to find out the root mean square error. So I'll import metrics from sklearn, and this is how I'll get the root mean squared error. So metrics.mean squared error, and this takes in two parameters, ytest and ypred. So ytest comprises of all of the actual values and ypred comprises of all of the predicted values, and I will pass these two inside mean squared error. Now when I do this, I'll get only the mean squared error, but I want the root mean squared error. So I'll use np.square root. So I would also have to import the NumPy library over here. I'll type in import NumPy as np. Now I'll click on run. So now we've arrived at our final interview question, and we'd have to build a decision tree classifier on top of this iris data frame, where the dependent variable is the species column and the independent variables are the rest of the column. So sepal length, sepal width, petal length, and petal width would be the independent variables, and your species column is your dependent variable, and the train test split is 70-30. So I'll start by loading the requisite packages, which are NumPy and Pandas. So import NumPy as np and import Pandas as pd. Then after this, I'll load my dataset. So pd.read_csv. I'll pass in the file name iris.csv and I'll store this in the iris object. and we have a glance at the head of this data set. So these are all of the columns present in this data frame. We've got sepal length, sepal width, petal width, and the species column. Now out of this, the species column is our dependent variable, and these 4 columns, the numerical columns, are our independent variables. So now I'll go ahead and separate the features and the target variable. So these are all of my features, these first 4 columns. So I'll just extract sepal length, sepal width, and petal width from this iris data frame, and I'll store that into this X object. Similarly, I'll extract only the species column from the entire iris data frame, and I'll store it into Y object. So I have my features and the target ready. Now it's time to divide this entire data frame into train and test split. So I'd have to import train test split from sklearn.model selection. And the stakes in these parameters. First parameter are the features. Second parameter is the object, which comprises of the target label. And the test size is 0.30. So 30% of the records would go into the test set, and the rest 70% of the records would go into the training set. And I'm storing the results into xtrain, xtest, ytrain, and ytest. So xtrain is the training set for the features. Xtest is a test set for the features. Ytrain is the training set for the target, and ytest is the test set for the target. Now we'll import decision tree classifier from sklearn.tree. So I will go ahead and create an instance of this decision tree classifier, and I'll name that instance to be classifier, and I will fit this classifier on top of the training set. So classifier.fit, and I'll pass in xtrain and ytrain inside this. So we have successfully fit the model on top of the train set. Now we'll go ahead and predict the values on top of the test set. So classifier.predict. So I'll store the result into ypred. After this, we'll calculate some metrics. So we'll get the confusion metrics, and we'll also get the accuracy score. Right. So this is my confusion metrics, and this is the accuracy. So the left diagonal which you see in this confusion metrics, all of these are the values which have been predicted or classified correctly. So this first row represents the species of Setosa, second row the species of versicolor, and the third row the species of virginica. Right? So you see that all of the species of Setosa have been classified correctly. When it comes to versicolor, 16 of them have been classified correctly, and 2 of them have been classified incorrectly. And when it comes to virginica, 13 of them have been classified correctly, and 2 of them have been classified incorrectly. So to get the accuracy, we'll have to add 12 plus 16 plus 13 by all of the values. So let me just do that. 12 plus 16 plus 13 divided by 12 plus 16 plus 13 plus 2 plus 2. So the accuracy is the same, and it comes out to be 91.11. So I hope this session was informative for you guys, and if you have any doubts, do comment below. We'll help you out. Thank you.